Hello everyone, today I want to start chapter 23, light optics. So I would like to talk about the ray model of light, okay, simply you can call geometric optics also. So I want to start from reflection of light. Reflection of light. Before starting this reflection of light, we need to know the ray. So what is a ray? Ray is the very narrow path of light, and you represent the ray like this. Draw the line and you can draw the pointer like this. This is a ray. So very narrow path of light. Very narrow path of light. This is called as the ray, and we know that the ray of light or simply light propagates in a straight line, always propagates in a straight line, and the collection of rays like this, collection of rays, this is called as beam. Okay, so this is a beam. Beam is the collection of rays, and this is a single ray. This is very narrow path of light. So this is a ray, this is a beam. Okay, and now let us define the reflection of light. Let us suppose you have, this is a plane mirror. Plane mirror. You can draw like this. This is a plane mirror. You know the plane mirror, the mirror you have in your bathroom. That is a plane mirror, or you can call dressing mirror also. And consider this is a ray of light. The light from the source. The ray of light coming from the source strike here, this point you can call point of incidence. This point, this you can call point of incidence. Okay, and let me call this point is O. The ray of light strike here at point O, and let me call this is I-O. So the ray of light strike on the plane mirror, and plane mirror is an opaque object. Light cannot pass through the plane mirror. It is opaque. Okay. So what happened is the ray of light after striking here, it gets back to the same medium like this. A ray of light striking on the opaque object gets back to the same medium. This is called as the reflection of light. So here IO, this is incident ray, and OR, this is your reflected ray. Light striking here at this point O, it gets back to the same medium. That is the reflection of light. Okay, so light coming from this way, incident ray, and get back to the same medium this way. So this medium, same plane, okay, that is called as the reflection of light after striking on an opaque object. Not necessary to be the plane mirror. Plane mirror you can easily observe that phenomenon, but if the light strike on any opaque object, simply light goes back to the same medium. Get back to the same medium, return back to the same medium. That is called as the reflection of light. And here you can see this is the ray. This is called as the incident ray. Incident ray. Okay. OR, this is your reflected ray. Everyone look here. IO, this is incident ray, OR, reflected ray, and right here at the point of incidence, right there at point O, you can draw the normal. This is the normal, ON. Here, ON is the normal, okay? This ray, ON, you can write down, look here, IO, this is incident ray, OR, this is reflected ray, and ON, this. ON is the normal at the point of incidence. You draw the normal at the point of incidence. So you can write down ON is the normal at the point of incidence. Okay, and look at this angle made by incident ray with the normal. This is called angle of incidence, and you can write down theta I, angle of incidence. Okay, and this angle, this is the angle made by reflected ray OR with the normal. This is called angle of reflection, theta R. So please note, theta I is angle ION. Theta I is angle ION. So this angle here, you can see incident ray makes an angle with normal, theta I, that is called an angle of incidence. Angle of incidence. And theta R, this is angle RON, this is called as angle of reflection. Okay, theta I, angle of incidence, and theta R, angle of reflection. Okay, so again, IO, incident ray, OR, reflected ray, ON is the normal, or you can call also normal ray. Okay, theta I, angle of incidence, you can see angle of incidence here, and theta R is angle of reflection, you can see the angle of reflection here. And there is laws of reflection, it is kind of important also, laws of reflection. This is really simple, very simple law. The first law is theta I, angle of incidence, is equal to theta R. Angle of incidence is equal to angle of reflection. Simple. Angle of incidence, always angle of incidence is equal to angle of reflection. Okay, and other law is, look at this, the incident ray, the reflected ray, and the normal at the point of incidence all lie on the same plane. So this plane here, plane of the board here. So the second law is the incident ray the reflected ray and the normal at the point of incidence. Lie on the same plane. Lie on the same plane. That's it. This ray, and the normal, they lie on the same plane. So if you think like this, one ray coming from this, and another ray, reflected ray, goes back. So this, and normal is right here. So this plane, all three rays, this incident, reflected, and the normal, they all lie on the same plane. And here in the diagram, all three lines, IO, OR, and ON, they lie on the plane of the board here. Okay, so this is the second law, the incident ray, the reflected ray, and the normal at the point of incidence. You have to draw the normal right here at the point of incidence. So all three lines, they lie on the same plane. And if you want, you can make another law also, that is like if you have a plane mirror like this. Let us consider this is a plane mirror, and if the ray of light strike like this perpendicularly, simply it retrace, it goes back to the same medium like this, 90 degrees perpendicular. Okay, so this is the reflection of light and laws of reflection of light. Okay, and here I use the plane mirror. Let us talk a little bit about the plane mirror. Okay, so the plane mirror you can draw this way also. Let us suppose this is the plane mirror. This is the plane mirror, and consider this is the ground. Okay, and you have an object right there. This is the object, and this object is from here. This is the plane mirror, and object is there. This distance from here to there, this distance you can use d sub O. D sub O is object distance. D sub O, this is object distance. Object distance. What is object distance? The distance from the plane mirror to the object distance. And if you have the image somewhere, the image distance is d sub I. You can use d sub I. This is image distance. But the question here is, I have an object here at this point. You can consider point O. This is a mirror. You can call, let's say, mirror M, uppercase M. So O is the object, M is the mirror. Where is the image? Where is the image? Can you draw the ray diagram? So it is important to draw the ray diagram. Ray diagram. So can we draw the ray diagram? Okay, to form the image, to make an image, you need at least two ray diagrams. Two rays, at least two rays. Let us suppose one ray is this. This is the incident ray. Another ray is, from here another ray is this. So I take two rays from point object, from here, from the object. It is a small object like a point size. So I take two rays. Now what is this? This is your plane mirror. Plane mirror. So what happened here then? This is the point of incidence, and this is also point of incidence. So what happened here then? You know that this is the opaque object. Light cannot pass through this plane mirror. So what happened? Light reflect then. This is reflected ray. Reflect from here, and another one is this. This is also reflected ray. So I have two incident rays, two reflected rays. Now look at this. These two reflected rays, they diverge like this. They never meet. So where is the image? To form the image, two rays, they must meet. But here look at this. These two rays, they diverge, so they don't meet. But what we can do here is, we can extend these rays like this. Draw the dashed line, don't draw the solid line please. Okay, you can extend the line here, this line. Draw the dashed line like this, and this is, you can use the ruler, okay? So my diagram is not quite good. So look at this right here. I extend these reflected ray and this reflected ray backward, and these we call the virtual rays. I extend them and they meet here. So this is the image. This is the image. And this length from here to there, you can use d sub I, image distance. Now this image is produced by extending these two reflected rays. But I told you this is dashed line. virtual light, virtual ray. So image formed, by these two virtual rays, this image is called as the virtual image. Virtual image. There are two types of image. One is real image, and number two, it is virtual image. So from this ray diagram, you can say that the image formed by plane mirror is virtual image. Okay, you can write down. Okay, so number one, the image formed by plane mirror is virtual image. Simply you know that this image is behind the mirror. So what is virtual image then? Simply the virtual image cannot obtain on the screen. The virtual image cannot obtain on the screen. Real image you can obtain on the screen. For example, do you know in the old types of camera we use the negative, the plastic film, that is the screen. Like a lens camera, you can, if you have a convex lens, the image formed by the convex lens you can obtain on the screen. That is a real image. Like we have a mirror, concave mirror. The concave mirror also produces the real image. But here in this case, the plane mirror, it formed the virtual image. We cannot obtain on the screen. That is why the image formed by the plane mirror is the virtual image. We cannot obtain on the screen. Number one, first property. Then the second one is, look at this. In plane mirror, the object distance, this of O, and the image distance, this of I, they are equal. In plane mirror, number two, in plane mirror, object distance, this of O is equal to image distance, this of I. Second property. And the third one is, you can think about, let us suppose you are in front of the plane mirror. You are 6 feet tall. Consider you are standing in front of the plane mirror, and let us suppose you are 6 feet tall. So what is the size of the image then, your image? If you are 6 feet tall, what is the size of the image? Behind the mirror. You see your image behind the mirror. So what is the size? How tall? 6 feet. So the size of an object is equal to size of an image in case of plane mirror. So in plane mirror, number 3, you can write down the size of an image is equal to size of an object. Okay, if this is the case, then if the size of the object is equal to size of the image, then in this case the magnification is 1. This means that is the magnification is 1. That means the plane mirror, it doesn't magnify the object. Okay, so simply magnification is equal to 1. We'll talk about the magnification in future in detail. Okay, so these are the basic things you need to know about the plane mirror. Okay, plane mirror, it produces the virtual image. In plane mirror, object distance is equal to the image distance. In plane mirror, the size of the object, or you can say the height of the object is equal to height of the image. Okay, therefore the magnification is 1. The magnification is 1. Okay, I want to give you one homework assignment here. You can practice this, just to practice, you don't have to submit. Let us suppose this is the ground. Okay, this is the ground. You have a plane mirror here. This is the plane mirror. and you are standing right here. This is you. This is you. Now let us suppose your height is 6 feet. 6 feet. You are 6 feet tall. So what is the minimum size of the plane mirror? Minimum height of the plane mirror. Minimum. Let us suppose you are 6 feet tall. So what is the minimum height of the plane mirror so that you can see your full image? That means you can see your head, you can see your feet. If you are 6 feet tall, what is the minimum height, or you can say minimum size of the plane mirror to see your full image? Please try this. Try this. I can give you the answer, but try to prove that. Try to prove that. You can see in the textbook also. If you are 6 feet tall, to see the full image, you need the minimum size of the mirror is 3 feet. If you are 6 feet tall, let us suppose if you are 6 feet tall, then the minimum size of the mirror you need is 3 feet, half of your height. To see your full image, you need the mirror. The minimum size of the mirror, it must be 3 feet tall. Please prove this. Prove. You can prove it, okay? I leave this for you guys. So if you are 4 feet tall, the mirror must be 2 feet tall. Then the minimum size, the maximum doesn't matter. Okay? So this is about the plane mirror. And there are, different types of mirror. One is plane mirror, the mirror you have in your bathroom, that is your plane mirror. And other types of mirror is simply, here I want to talk about the spherical mirror. Okay. The spherical mirrors is something like this. Let us suppose you have a big sphere. This is the sphere, hollow sphere. Okay, and you cut from here. You cut, make it 2 parts. And so one is this. Another one is this. Okay. Okay, now if you coat this side, if you silver this side, this mirror is called as the concave mirror. Concave mirror is like this. Look here, everyone, like this. This is the concave mirror. Look, this is like a cave. So you have a big sphere, and you don't have to cut right there. This is the part of the sphere, and you coat. This is a silvering. We call silver coating here. So this is the concave mirror, similar to this. Okay, this is the concave mirror. Okay. Now the other one is if you coating is this side. Silver this side. Okay. So it is like this. Look here. This is the reflecting surface. But you coat silver this side. Okay. So this is, balls out here. So this is the convex mirror. Okay. So this mirror is convex mirror. So we'll talk about these 2 types of spherical mirror, convex mirror and concave mirror. There is another one, the parabolic. We do not talk about that parabolic types of mirror here. So we have to talk about this convex mirror and concave mirror. You can think about like a steel spoon. The spoon? The spoon is something like this. So steel, okay? Steel spoon, kind of new steel spoon. Spoon is something like this. So this side is concave, this side is concave, and the other side, this side, it balls out here. So this side is convex. So if you take a spoon, kind of new spoon, okay, and if you look if you bring the spoon close to your face, this side, then you see really funny face there, funny image. That is, this one is a concave and this one is convex. Okay. Now let us talk more about these two mirrors. First I want to talk about the concave mirror. Okay, let us suppose this is concave mirror. And I told you that this mirror is part of the sphere, kind of big sphere. So I took the certain part and I silver this side, so it becomes a concave mirror. So this is your concave mirror. Okay. And if this is part of the sphere, the center is, let us suppose the center of the sphere is somewhere there. This is center, we call center of curvature. This point, this is center of curvature. Center of curvature. Actually, it is center of the sphere. And this point, let us suppose this point is, my diagram is not quite good, guys. Okay. So this is, let's say, I can call O. This is center of the mirror. You can call pole also. This point, this is the center of the reflecting surface. This is the center of the reflecting surface. So you can call pole. And if you join the line, straight line like this, join this. Okay. If you join these 2 points, this line is called as the principal axis. The line joining the center of curvature and the center of the mirror pole, that is called as the principal axis. And from here you can call this point is C, this point is O. This length from here to there, from this point to this point, center of curvature to the pole, this is called as the R. It is the radius of curvature. Radius of curvature. Okay, so we know the pole, center of the mirror, reflecting surface, center of the reflecting surface. There is a center of the sphere, and part of which is the mirror. So this point is simply we call center of curvature. The line joining the center of curvature and the center of the mirror, that is called as the principal axis. And the distance between the center of curvature and the center of the mirror pole, that is called as the radius of curvature. Only this. Okay, so this length is called as the radius of curvature and represented by R. You can use uppercase R or you can use lowercase r, it's up to you. Okay, now let me redraw this again. This is my concave mirror. I'm redrawing, and here I have a center, and somewhere there I have a center of curvature. So I can draw the principal axis. Okay, this is my principal axis. This is the principal axis. If you want, this is your C, this is your O, center of curvature, center of the mirror, and OC is the radius of curvature. Okay, if you want, you can extend this line. You can extend, if you want, you can extend even behind the mirror also. You can extend this line. You know, this is the principal axis. Principal axis. Okay, now the concern here is, how do you draw the ray diagram here? How do you draw the ray diagram? This is important. Okay, so the concave mirror, in case of concave mirror, this is straight line. You have to draw the straight line. Please use the ruler. Okay, my diagram is not quite good. Use a ruler and you can draw. Okay, here you have to draw the ray diagram. And if you keep the object like this is my, I'm talking about this mirror. If you keep the object very close, you can see the image is different. It is not like a plain mirror, it is a spherical mirror. So if you keep the object here, or if you keep the object really far, the size of the image is different, the nature of the image is also different. So if you keep the object in front of the concave mirror at different position, you get the different nature of image. Now let us suppose your object is really very far, very far. So if the object is very far, we call that object at infinity. Okay, object at infinity, very far, infinity. Okay, object is very far. So how do you draw the ray diagram? In that case, simply if the object is at infinity, you simply draw the line like this. This is the ray coming from the object which is really very far from the spherical mirror, concave mirror. You need at least two rays. Okay, so another ray is this. So these two rays, they are coming from the infinity because your object is really very far, like a sun. So in a numerical problem also, if the question says something like object is really very far, in that case your object distance is infinity. If the object is really very far, then in that case your d sub O is the object distance, right? So this is infinity. If the object is at infinity very far, then your object distance is infinity. Now what happened in this case? Of course, look, this is the point of incidence here. This is also point of incidence, and this is the mirror. This mirror also obeys the law of reflection. Angle of incidence is equal to angle of reflection, no doubt. Okay. So what happens is right here, light reflect like this. This is, don't forget to keep the arrow pointer like this. This is incident ray. This is reflected ray. Reflect from this point, and look, you have a second ray from here. Light also reflect from there too, from here too, and here also you can draw like this. This is reflected ray. Now look at this. This reflected ray and this reflected ray, they meet at this point. If you take another rays like this, parallel, okay, parallel to the principal axis. If you take another rays like this, all rays after reflection, they meet here. They go like this. They go. All rays, they meet at this point right here. They meet at this point right here, roughly. Okay. There is some defect, we call that spherical aberration. Okay, so that is a different story. But simply, the parallel rays after reflection, they meet, they focus at this point. And this point is called as the focal point. Focal point, and you can give the name F. F is the focal point. Now look at this. This is your center of curvature. This is your center of curvature. This point is focal point. This is the pole. And here, from here, OF, you see this length. OF here, okay? OF is this length, OF, this is called as the focal length. You can use lowercase f, okay? So everybody look here. OC, I simply use R, okay? This is the radius of curvature. Radius of curvature, and OF, you can use lowercase f. This is the focal length. And R, the radius of curvature R, this is equal to 2 times the focal length. Try to prove this. It is easy, okay? The radius of curvature R is equal to 2 times the focal length. Don't forget, you need this. The radius of curvature r is equal to 2 times the focal length, and this is the case if you keep the object at infinity. What happened? Look here, this is the case if the object is at infinity. Don't forget, I have a principal axis, I have the center of the mirror pole, I have the focal point, I have the center of curvature. You need to know the principal axis, focal length, radius of curvature, everything. Okay. Now the next one, in this case object is at infinity. So if I keep the object at different position, what happens? Let me draw a couple of diagrams in case of concave mirror. Okay. So this is my concave mirror. The best way is, if you want to draw this, you don't have to memorize anything. Just simply take ruler, protractor and pencil and take a piece of paper, okay, and draw the principal axis using the ruler. So principal axis, the horizontal line, draw the principal axis like this, okay, and you can choose, let us suppose this is your focal point F. This is the focal point F. If this is from here to there, if this is, let's say, 5 centimeter, now you have to choose the C, center of curvature, C. So if this is, if the focal length, this is the focal length, if this is 5 centimeter, this must be 10 centimeter. Use a ruler, okay. So I already, drew the diagram, ray diagram, if the object is at infinity. This time I want to keep the object right here then. I want to keep the object right there. So how do you draw the ray diagram then? How do you draw the ray diagram then? In this case, what you can do is, this is the object, you can write down O, O prime. This is the object. This is the top and this is the bottom. Head and foot. Okay. So one ray you can take parallel to the principal axis like this. Use a ruler and draw the rays like this. Draw the rays like this. This ray is parallel to the principal axis. If the ray is parallel to the principal axis, after reflection, it passes through the focal point like this. Don't forget to draw the pointer. This ray parallel to the principal axis, after reflection, it passes through the focal point. This is the focal point, okay? This is the focal point. But I told you that to form the image, you need at least 2 rays. So another ray, there are thousands of rays, but you don't have to do all of them. So another ray you can take from, like, use a ruler, you don't have to memorize, I told you, okay? So you take another ray from the focal point there. My diagram is not quite good, guys. I told you that I'm not using any ruler here. Something like this. Okay? It is a straight line. You don't have, you cannot make a curved one. Okay? So another ray you take from the focal point. So if the incident ray is passing through this point, focal point, after reflection, it passes parallel to the principal axis like this. So this is a reflected ray, this is the incident ray. Look, after reflection, this ray is parallel to the principal axis. Now where is the image then? Look at this. This is one reflected ray, and another reflected ray is here. These two reflected rays, they meet right there. So your image is here. This is your image. This point is the image of this point. So this object is up. Look, we call upright. This image is upside down. Look, this is upside down. This is the image. You can write down I prime. This is up, upright. This is inverted, upside down. This one is, object is upright. This is inverted. Okay. So if you keep the object, this is the object in front of the center of curvature, your image is formed in between focal point and center of curvature. if you keep the object in front of the center of curvature, the image formed in between center of curvature and focal point. In this case, okay. So the second case, object in front of C. C is the center of curvature. What happened in this case? Image formed in between C and F, center of curvature and focal point, C and F. The image formed in between C and F, number one. Number two, the image is smaller than object. I told you that I'm not using ruler. You see that I'm not using ruler, protractor, nothing. So I'm just using my hand. So if you use the ruler, if your measurement is proper measurement, exact measurement, you can easily observe this. You can easily see this. This image is smaller than this object. Okay. So in this case, the image is the size of the image. Size of image is smaller than size of an object. And of course the other one is, you can write down another point. Look, the image is inverted. If you see the inverted image, it is real image. This image is real image. So you can write down third one, image is inverted and real. So what happened here? The size of the image is smaller than size of the object. That means the magnification is less than 1. Your size of the object is bigger than size of the image. Therefore, the magnification is less than 1 here. So these are the basic point you need to know. Okay. So here I keep the object in front of the point C. Now what happens if you keep the object at point C then? What happens if you keep the object at point C, which is the center of curvature? Let us do that quickly. Okay, let us suppose this is your concave mirror again. This is your concave mirror, and here you have your principal axis. You use the ruler protractor, okay, so you will get the perfect diagram. So this is your focal point and this is your center of curvature. I told you that this is the focal length and this is your radius of curvature. Radius of curvature is 2 times the focal length. Always keep that in mind. And these times I want to keep the object right here. If you keep the object right here at point C, this is the third case. Object at C. Object at C. What happened in this case? Okay. Idea is again same. You can take a ray like this parallel to the principal axis. Okay. After reflection, this ray passes through the focal point. Okay. So this is the reflected ray. Then another ray you can take from here, from the focal point, like this. Okay. Don't draw the dash line. You have to draw the solid line. Okay. Like this. Okay, draw the solid line. Then after reflection, what happens is it goes like this. This is the second ray you take from the focal point, and after reflection, the reflected ray is parallel to the principal axis, and your image is right here. Image is right there. Okay, image is actually image formed at the same point. Please use the ruler. Image, if you keep the object at C, the image formed at C. Same point. But the image is inverted. Image is inverted, but it's formed at point C. This size, the size of the object is equal to size of the image. So here, if you keep the object at C, in this case, image formed at C. Same point. Number 2, size of an image is equal to size of an object. This means magnification is 1. If the size of the object is equal to size of the image, then in that case the magnification is equal to 1. And number 3, image is inverted, upside down, inverted and real. Okay guys, now you see that if you keep the object at infinity, image formed here. If you keep the object at infinity, image formed at the focal point. If you keep the object in front of the point, see somewhere there, then the image formed in between C and F right there before. We did this before. Now if you keep the object at C, image formed at C. So object at infinity and you are moving toward the mirror. What happened to the image? If the object come closer, then the image move away. So object at infinity, image there. Object at in front of the C, image is there. Now object at C, image is also at C. Now if you keep the object here in between C and F, your image is formed somewhere here. Please try that. I don't have a time today. Okay. So now next is keep the object here. What happened if you keep the object here? You can keep object there. What happened if you keep the object at focal point right there? That is interesting. If you keep the object at C, please try this. This is interesting. And what happened if you keep the object inside the focal point? Everyone, I want to give you the another practice homework. Okay, if you keep the object, these two, please try this. This is your concave mirror. Here is a F, here is C. Okay, so if you keep the object here, what happened? Complete this ray diagram, number 1. And number 2 is again same spherical mirror, concave mirror. Please try this also. So here you have a F, here you have a C, and you keep the object there. If you keep the object here, what happens? This is inside the focal point. This is at the focal point. Please complete this. You don't have to do anything else. Just simply use a ruler and protractor. Okay. Try this. We'll discuss in our discussion section somewhere. Okay. So this is about the concave mirror. Concave mirror, you have a different. You can keep the object at different position. Now, what about the convex mirror then? What about the convex mirror? Convex mirror. Okay, convex mirror you can draw like this. This is your convex mirror. You know, in convex mirror, the center of curvature is somewhere there, behind the mirror, behind the reflecting surface. So, and this is your center of the mirror, center of the mirror. This is center of the mirror. This is center of curvature. So, if you join the line like this is your radius of curvature. This is your radius of curvature, everyone. This is radius of curvature, and your focal point is right there. This is your focal point. This is your center of curvature. If you have to extend this, you can extend like this. This is principal axis. Okay, straight line. Okay, don't draw the curved line. This is the principal axis. This is principal axis. Principal axis. This is focal point. This is center of curvature. So this length, let me call this is O. OF. OF is focal length and OC is radius of curvature. Okay. Now how do you draw the ray diagram here? Let us suppose the object is at infinity, really very far from the mirror. So if the object is far from the mirror, let me erase this. If the object is far from the mirror, you simply draw the line like this, parallel line. This means object is at infinity. So what is this? This is the convex mirror and this is the reflecting surface. This one, like this. This is, I already showed you this. Okay, so this is the reflecting surface. This is a convex mirror. So ray is coming parallel to this. Like you know, you have your on your side, the driver side, you have two mirrors there, the in your car, that is the convex mirror. Okay, so how do you draw the ray diagram here then? So object at infinity. So it is very simple. In concave mirror, the reflected ray pass through the focal point, but of course here the ray cannot pass like this. Cannot pass like this because this is the opaque. So what happens? It reflect like this. This is the reflected ray, and here this is also reflected ray. Now look at this. This reflected ray and this reflected ray, they don't meet. If these two reflected rays, if they don't meet, you cannot produce the image then. So what happens in this case is, you have to extend this line. Please draw the dash line like this, and you can extend this line also. And look, they meet right here, focal point. So if the object is really far from the convex mirror, the image formed here. This is the position of the image. Image formed at focal point. The image in this case, image formed at the focal point, and diminished. Diminished means the size of the image is very small, almost like a point size, very small. If you look on the mirror on your side there, let's say the truck is following you behind you. Then if you see your mirror, you see the truck there, but the size of the truck, the size of the truck image, that it is really small, because that is a convex mirror. Okay, but here my object is not like a truck, it is really very far, so the image is almost like a point, very small size, we call diminished. Number one. Number two, and this image is produced by extending the line, so dash line, virtual ray. So the image is virtual. The image is virtual. I cannot obtain this image on the screen. And it is upright. If the object is upright, this is also upright. Okay, no inverted. Okay. So this is the case if the object is at infinity. Okay, and this is the convex mirror. In case of convex mirror, we don't have too many. So if you want to draw another one, if you keep the object like, let us suppose second case, let us suppose here you have a F, here you have a C, and if you keep the object right there, now it is close to the mirror. You do the same thing, take a ray parallel to the principal axis, then after reflection, it goes like this. What is next? Another ray in this case you can take from this point. Look at this, I can do like this. If you take a ray from this center of curvature, so in this case right here it is perpendicular, so if the ray strikes perpendicularly, ray goes like this and it returns, it reflects, it retraces the same path. So now look, if you extend this line, these two rays, they meet here, right there. This is the image. Image is here. This is object O prime, and this is your I prime image. Okay. So if you keep the object in front of the convex mirror, close to the convex mirror, not infinity. Okay. So image formed. This is your pole. Okay. In between the pole and the focal point. And look at this. This is the object big. This is the image small. So here also in this case, the image formed in between the focal point and the center of the mirror, number 1. Okay, and number 2, image is inverted, sorry, image is upright, object is also upright, image is upright, and it is a virtual image. If the image is upright, that image is always virtual image. Okay, and the image size is smaller than the object size. Image size is smaller than the object size. Okay, so here also we have to talk about the object distance, image distance, focal length, radius of curvature, like this. Look at this. For the spherical mirror, for both convex and concave, we have this of O, we have this of I, and we have F. What is this of O? This is object distance. Object distance. What is this of I? This is image distance. Image distance. What is F? This is your focal length. This is your focal length. So there is a formula. We call the mirror equation, mirror formula. And the mirror formula is we can derive this formula also. 1 over F, 1 over focal length, 1 over F, 1 over focal length. This is equal to 1 over object distance, this of O, plus 1 over image distance, this of I. This of I. So this is the mirror formula. This formula is really simple. We can prove this also, but the proof is not that much important. So if I get a time, sometimes I can prove this maybe in my next lecture. So 1 over F is equal to 1 over this of O plus 1 over this of I. This is the mirror formula. Mostly you need this formula to solve the numerical problem. Okay. So I have to stop this lecture right here. So I'll bring another video. Okay. Thank you.